And I want to do a real short presentation that's kind of will be supplemental to my presentation that I did a few weeks back on gravity. And I think that this time I can put this in such a way that anybody can understand it, because really, you know, when I went through, what was it, Thornhill's video, and this, of course, he is the lead investigator of the electric universe theory, the EU theory. And you know, I've been following their work for a long, long time. There's no doubt in my mind that everything about this universe is electric, electrostatic, electromagnetic. They are definitely on the same thought line with us, except of course they're not flat earthers, but that doesn't matter, because that doesn't, you know, take any legitimacy away from their research in the least. But Wall, of course, in this particular presentation about gravity, he talked about essentially gravity was an electrostatic effect that was done by the alignment of dipoles in any piece of matter. And I went through that in depth. I'm not going to go over it again. Anybody who wants to recheck it, go back and look at this. But what I am going to do today is I'm going to elaborate on it and simplify it a bit. And I want to go back to one of my favorite researchers, of course, who is Ken Wheeler, Theoria Apophysis. And my God, how did I get unsubscribed from him? That is so weird. YouTube is messed up.
Yeah, that's been happening to a lot of my subscribers too. It's makes me mad.
Yeah, that's bizarre, because I just noticed that I wasn't subscribed. It's like, no way, I've been subscribed forever. Anyway, all right, so I was watching, you know, some of his videos and, you know, kind of going over it. And in this particular video, he said something that really, really struck a chord with me. And I'm going to go ahead and play that really quick, and then I'm going to elaborate on it and say what I got out of it. So let's go forward from this point here for just a minute or so.
Okay, gravity is nothing other than dielectricity. Gravity is no different than turning on your TV set and actually shining a light off from the side, and you're seeing little dust particles actually head to the TV set and stick to the TV set. That's why you're running your TV set, especially little CRT tubes, got so dusty. The dust in the air would go gravitate to the front of the that is the exact same thing as gravity. People think that that is an electrostatic charge, or like you charge a balloon up and you pull someone's hair to it. That same acceleration, not force, that same acceleration is what we ignorantly call gravity. Gravity itself is an autonomous acceleration, of which a lot of people call it incorrectly a force, does not exist. It's like, what do you mean gravity doesn't exist? Obviously I can drop this and there's gravity. What I mean specifically is that gravity does not exist. It is not an autonomous force. It's definitely not a force, which of course even the idiots of general relativity and quantum mechanics will admit to. They call it an acceleration. But an acceleration of what? By what? We need explanations, not descriptions. And all that general relativity and quantum mechanics provides are descriptions, not explanations. It is.
Yes, okay. And that is absolutely correct. They just describe things, and you know, they don't ever explain anything. And the same goes for math. Math is a tool that's meant to describe, not to solve things, not to explain things, and of course it does not. That's one of the biggest conundrums that many of the ball earthers have fallen into. They believe that math simply proves everything, and it just does not. But I digress, and we won't go there. So anyway, the thing that struck me that Ken Wheeler said in this in a whole new way was when he said, you know, when you have a TV screen, and you know, the old CRTs, and you know, many of us remember those before the LCD and LED TVs came out. Always we had a problem with dust being attracted to it, or you could, you know, throw a piece of paper at it and it would stick to it. All kinds of things would stick to the front of the TV screen. And it just occurred to me, oh my God, that's absolutely correct. And as many of you know, I have talked many times about the times that I've been up on a tower doing tower work, and if you come across anything at ground and you're 50, 150, 200 feet above the ground, you get shocked, and you get shocked in a big way, and it hurts, right? So when Ken made his statement about the static electricity, you know, being exactly what the effect of gravity is, that really got me thinking, and of course it very much resonated with me. So what I started looking into is some of the videos about electrostatics. And electrostatics, it doesn't seem to really care what it attracts to. It is primarily, well, it can be either an attractive force or a repulsive force, depending on the polarity of the circuit that you're working with. Now, there's one other video here that I'm just going to kind of play in the background, but what he's doing is he's simply going to make the point that several things are electrostatically attracted, and it doesn't matter if they're metallic, it doesn't matter if they're wood, it doesn't matter if they're plastic. Electrostatic seems to have this exact same effect on everything. Here he's got a charged straw, and it's being attracted either way to his hand. Okay, so he's showing that. Then he's going to come up and he's going to put a straw in here again, and he's going to bring other objects in the vicinity of it. Now we've got a metallic object. I think he's got a fork there or a knife, something like that. And it's being attracted to it. So it doesn't matter if it's biological material like us, or dust, which would be dirt, or now he's going to use glass, or I think that's a plastic bottle, or maybe it's glass, I'm not sure. But he uses glass, and he uses all these different materials. Here we've got wood. Wood is attracted to it. So it's the electrostatic force, really, and even a thing of garlic salt, that he's making this point about, okay? So obviously the point here is that electrostatic energy can be very attractive, or it can be repulsive, but in our context in gravity, obviously we're using it as an attractive force. Now he also will take other objects, like this knife, and he'll reverse it by taking the knife and putting it up there, and then he is, what's he doing here? Then he's putting a plastic piece next to it, and we've got, again, this attractive force again. So long story short, electrostatics very definitely seems to attract everything. There's very few things, if any, really, that it doesn't have an effect on. Oh, he's got a comb there. And so that's kind of the point of the whole thing. So to elaborate on this even further, I started thinking, it's like, yeah, there is a lot of static electricity out there, through my own experience. And of course, this kind of brings us back to, what is the Earth being powered by? I've talked about the Earth being a circuit, essentially, with the Earth itself being negatively charged as a cathode of a circuit. And then, of course, as you go up into space, we seem to get more of a positive charge. So I started looking into mainstream physics for explanations about this, and see if anybody had actually written about it in detail. And lo and behold, I absolutely did. One other thing that is interesting, when you start looking into atmospheric electricity, you start seeing these corona motors, or electrostatic motors, that are run specifically off of static electricity. Okay, so I'm going to play this little part right here, and listen to what this guy says. He is referencing a book written by Richard Feynman. And of course, if you know who Richard Feynman is, he's definitely a quite well-known physicist. But Richard Feynman did quite a study in this, and actually came back with some very solid numbers. So let's listen.
Before you start that too, another interesting video I recently watched was from the Sunbeam car manufacturer, and I forget what channel it was on, but it's similar. They're essentially pulling, electrostatic charge or whatever, just simply out of the ether, and converting it into, electric current. So anyway, it's cutting edge, and I think that they're probably all pretty much borrowing, or at least leaning a bit on Tesla's work, which I think is great that it's finally sort of getting out in the mainstream.
Yes, this is absolutely Tesla's idea initially. And of course, that's what Tesla's work was based on entirely. And he even talked about being able to broadcast power through the Earth itself. And I'm not exactly sure how that works. I did watch a 3.5-hour presentation by Eric Dollard this weekend, which was fascinating, that actually went into depth on that a little bit better. And once I understand it well enough where it's, it's fairly simple to me, then I will try and turn it around and explain it in simplicity to everybody else. But you really have to understand something fairly well before you can explain it simply. And I'm not comfortable with doing that yet with Eric Dollard's work, but needless to say, he's very much on board with what Tesla was saying about this. So I'm going to go ahead and play this and listen to what Richard Feynman says about this and the numbers that he comes up with. So here we go.
How it works. Much of the following explanation is adapted from Nobel Prize-winning physicist Richard Feynman's lecture on physics, a section called Electricity in the Atmosphere. For every meter you go up in the air, the voltage increases by around 100 volts, or we could say around 100 volts per yard. We can draw these voltage increases using what are called equipotential lines. Notice that the ground is negative and the sky is positive with respect to each other. According to Feynman, this extends upward to 50 kilometers, or 31 miles, where the air is very conductive. This is the case in fair weather. In stormy weather, like a thunderstorm, things are quite different, and I won't talk about that here. But if this voltage exists between your head and the ground, why don't you get a shock? The reason is that your body is a good enough electrical conductor that standing on the ground, you're basically a part of the ground.
Okay, so what he basically just said is that it's going up to several miles up into the atmosphere. And let me see, what did I write down about this? So that it goes up 50 kilometers, according to Richard Feynman, or 31 miles. And at 100 volts per meter, that leaves us with a static potential in the air between the Earth ground and 31 miles up of 5 million volts. Okay, that's not that's not a small figure, believe me. 5 million volts is a lot of energy, a lot of voltage. Now, the thing about this static electricity is, even though it's extremely high in voltage, it's very, very low in current. So fortunately, when you're down at the lower levels and you go up on a tower and you're only experiencing you know, a few thousand volts of that static electricity, because of the fact that the current is very low, it won't kill you. However, it does hurt, you know, as I've said many times. So here we have Richard Feynman, which is talking about this electrostatic field, which is emanating from the Earth and essentially acting as a cathode. Now, if you have a cathode, that must mean that you have some sort of an anode to complete the electrical circuit of the Earth. And of course, that anode would speculatively be the firmament, if you will, or, you know, if it's even physically up there. Otherwise, I'm not sure, because typically you have to have something to complete a circuit before you get any type of current flow. But the bottom line is that it is documented in mainstream physics by Richard Feynman that we have got this electrostatic potential, this fantastic electrostatic potential that's coming off the Earth to the tune of 5 million volts up. Well, so let's think about that for a second. What did Ken Wheeler just say? He said, well, if you've ever looked at an old CRT, you know, your old television set, and you shine a light on it and you can see all these little dust particulates, you know, being drawn towards this CRT, that is exactly what the effect of gravity is. And it's like, wow, that's what struck me as so strong, because we have that static electric potential off of the front of that CRT, which draws everything to it, and it doesn't seem to care what it is. And lo and behold, we have that exact same condition, except with a much, much higher static potential on the Earth itself, documented by mainstream physics and even broken down to 100 volts per meter. So what does that tell us? That tells us that, wow, it doesn't take a great leap of faith or logic to then see that what Wallace Thornhill was talking about the static dipole effect attracting everything to it, that it is indeed the Earth itself that sets the potential that determines up from down. And of course, any of you that have been following Globebusters for a while knows that my position on gravity has always been that, yes, I totally believe in the density and buoyancy argument. However, since day one, I have said there is still something that is determining up from down. Okay, and this is it. This is actually it. It's the static potential between the ground and the sky itself, proving unequivocally that gravity is an electrostatic force, which of course is all part of the electromagnetic circuit that we've talked about on Globebusters. for several weeks here.
Yeah, I totally agree, and I've always felt that it must be some sort of an electromagnetic or possibly some other form of density that we've not thought about. But yeah, this makes perfect sense to me, and it does indeed answer the or solve the question, what causes the buoyant and density, buoyancy and rising effect. Because again, you have to have down and up. And I think that this perfectly explains it. So yeah, awesome.
Yes. So anyway, that's why I got excited when I heard that, because it's so funny. You can have something right in front of your face and yet for some reason not see it. And Jaron, how many times have I talked about me being up on a tower and getting the crap knocked out of me by static electricity, and it never occurred to me. It's like, oh my God, here it is. The entire Earth is the static thing. Well, what also that means is that that tells me that we are absolutely a part of this circuit. We are integral to it. And what that also tells me is that we can never really leave Earth, so to speak, because otherwise, what would happen to our own electrical or electromagnetic field and electrostatic field that is around us? Because it seems to be an absolutely integrated part of the Earth itself. We are part of this Earth. And I don't think that there's any way to ever really escape it. And that's something that we're going to be looking into even further and further. So the idea of going to a moon or other planets, basically we're going to be escaping the confines of this magnetic thing. And of course, in the flat Earth theory, nobody can ever really go above 100 miles anyway. So obviously, I don't think that's ever going to happen. But this gives us a very good basis to work from, understanding that Tesla was right, Heaviside was right, Poincare was right, James Clerk Maxwell was absolutely correct, and Einstein, of course, as always, was an idiot, because he had no idea what he was talking about. Well, and maybe he did, maybe he didn't, but he was definitely
he exonerated himself like right on his deathbed, I think, right?
Yeah, he said something to the effect that even I can't stand behind my own theories, which was probably the most honest thing that he ever said.
Yeah.
So in absence of Einstein, then we have all these other major league, physicists that have all been saying the exact same thing, that, gravity is a product of an electrostatic force. And here it is right in front of our face. It's always been here, and everything is going to be subject to this. Now, one other thing that I'm going to be going to, and not today, but it started making me think, well, what about things that are lighter than air and stuff like this? What is exactly the molecular composition of like hydrogen and helium? Of course, we know they're very simple, but it's also because that they have this very low charge, that they would be not so susceptible to the static charge that the plane itself is putting out, to the tune of 5 million volts. And of course, Feynman only said that this goes up to, and I don't know where he got this, but he said 50 kilometers or 31 miles. It's interesting that he said that, and I don't know how he arrived at that, but that's something that we're going to be looking into. But the bottom line is he's telling us that there's a static potential of 5 million volts between the Earth and 31 miles up, or beyond. And that brings us all the way back to, what exactly is powering the Earth. And that's something we're going to be looking into in depth, because the Earth simply must be a circuit. We have the static potential, we have the electromagnetic potential, we have the fields that are there that are blatantly, well, they're demonstrable in a lab. I mean, we can do all of this stuff, but now we have a pretty solid understanding that I don't think that anybody is going to be able to debunk this. The fact that the Earth plane itself is a huge electrostatic attractive device, and that is what's giving us our up from down. Now, obviously, if the polarity could be reversed somehow, where the Earth itself was positive and the sky or the anode was negative, then I think everything would probably go floating up. We would be floating up in the air until we hit whatever the anode would be. But of course, that's pure speculation because we don't know. However, I can tell you that in electrical theory and in electrical practice, we can certainly replicate that idea in a lab. easily. And in fact, I don't think anybody is even going to give us any static over that. Pardon the pun.
Well, and keep in mind too that, you know, during the phase of history when gravity was being postulated, they didn't have a frickin' clue about electromagnetism, so it's no surprise that they wouldn't have included it in their model.
Exactly. That's right. They didn't know much about electricity or electric circuits, and therefore, you know, they saw lightning. Oh, and the other thing that's very interesting as well is, I mean, when you start looking at lightning, and you've got sprites, and you've got the other component of sprites, which I can't. It escapes me right now. But what's interesting is when you see those things discharge. No, it's not ball lightning. It's elves, sprites, and elves,
And goblins.
Yeah, and goblins. But you see some very interesting phenomena when you look at those in high speed film. And what happens is those sprites discharge up to the anode, and when they hit that anode, whatever it is, whether it's an actual firmament or, you know, a static charge plane or whatever it is, you see them spread out over this area that appears to be like a solid glass or something. So we see this all the time. It's right here in front of our face, and the static electricity seems to be trapped in between this thing that the sprites and elves are propagating up to, and of course lightning, which is propagating down to the ground. So we're seeing this electrostatic potential, and then of course when you get storms and, you know, moisture in the air, you are changing the resistance of the atmosphere itself, and of course there will be static discharges, very much like when you walk around, you know, rubbing your feet on the carpet, and you walk up to something metal and stick your finger next to it, it discharges. Very same thing. All that's happening, you know, during weather systems is we are, because of the moisture in the atmosphere and whatnot, it's actually changing the actual electrical resistance of it, and then you will see saturation and discharge conditions, which again are provable all day long in the lab. They're demonstrable in a lab. I mean, now we're back on a plane where we're not dealing with any woo-woo, ridiculous gravitational force caused by the collapse of two black holes a long time ago in a galaxy far, far away. Now we're dealing with it right here at home with things that we can look at, that we can test, that we know for a fact are there. Even our own mainstream physicists are telling that, yes, it's there. And here we have our 100 volts per meter, which, or yard, whatever you want to look at it, but he specifically said meter. And that's great. You know, there it is. So gravity, sayonara, you don't exist. The whole concept of it, when the apple fell on Newton's head, what was happening is that apple basically succumbed to the electrostatic pull that was emanating naturally from the earth, probably up to the tree, I don't know, maybe 10 or 20 feet. And if it's, you know, that would give you a static potential between the ground and the apple of maybe 1,000 volts or so, you know, something like that. It's there. It's very obvious. I mean, what more can we say about it? You know, gravity is an electrostatic force. Gravity, as it has been explained to us by Newton, by Einstein, and by all these other idiots that think that it's caused by, you know, some woo-woo effect, action at distance. Sorry, it's much simpler than that. And then, of course, they've just completely gone overboard in trying to prove it when it's quite simple. You know, a little TV, a little CRT TV with dust sticking on the front of it was the answer to gravity all along. There it is, and I hope everybody can understand that, because I can't make it any simpler.
No, it makes perfect sense to me.
Yeah, I think so. What do you think, Jaren? Oops. Oh, Jaren, you're muted. There you go.
Sorry, I was on mute. Yeah, no, I think it's perfect. Absolutely perfect.
Yep. And again, if anybody wants to go back and get the physics breakdown of it, again, this video, and I'll put this in the show notes. I'll put all this stuff in the show notes. But, you know, Thornhill did a beautiful job, and of course I reiterated it a few weeks ago, about how the electrostatic dipole alignment was causing this force. But the reason that it is such a weak force, and it's a very weak force attractively. Okay, even when you get up to 5 million, but as a theory, it's not a force. Okay, first of all, I need to stop saying that it's not a force. As Ken Wheeler said, it is. It has attractive properties, but it is an acceleration that is causing this. And it's interesting because, you know, when you guys watched, when we watched Felix Baumgartner jump, you know, do his jump, and when there wasn't a whole lot of atmosphere up there to slow him down, we saw you guys, we would see his acceleration towards the earth. I mean, absolutely start accelerating. It didn't start out constant or anything like that. And he got up to an outrageous amount of speed before he started getting into an area of the atmosphere where it started providing enough wind resistance that it was slowing him down. And he finally got to the, you know, standard terminal velocity figure that most skydivers deal with of 120 miles an hour. But before that, he was spinning wildly out of control, and he was coming down at an unbelievable rate of speed and accelerating. And he would have continued to accelerate had he not run into the atmosphere, which was actually starting to slow him down. So Ken Wheeler, Theoria, is absolutely correct in that, saying that this electrostatic potential acts as an acceleration on objects back down towards the Earth. So there you have it, gravity. Who knew?
Awesome. And, you know,
Yeah.
I think I remember, and perhaps it was Tesla describing the Earth itself as a capacitor plate with essentially unlimited potential. And, you know, I see this as a perfect example. You know, the dust on the old school screen is a perfect example. I mean, could you imagine if that screen had unlimited potential, how attractive that force would be? So, yeah, pretty awesome.
Yeah, it really would be, because I mean, obviously, if you kicked it up to 1 trillion volts, then the acceleration would be, and the gravitational constant that they came up with would be, you know, substantially higher. And at that point, we would probably not even be able to lift our feet off the ground, if you will. Also, here's the other thing about this that I find very interesting, is that this electrostatic potential, basically all it does is serve as the accelerating force, you know, and not a force, but the accelerating agent and the attractive side of the equation, but it simply does not have the electrostatic attractive potential to hold fantastic weights down. In other words, what I'm saying is that you know how a bird can go and fly away, but yet it holds millions and trillions of tons worth of oceans down. Well, again, that is a product of the density and buoyancy argument. And that, of course, is an entirely separate argument altogether, because all we were really looking at is what is it that is creating this accelerating force downward, and that would be the static, and that also gives us our directions of up from down. But electrostatically, you know, just like if you take little pieces of paper and let them fly towards a balloon and stick to a balloon, you can simply blow on them and they'll disconnect and, you know, and come away from that. So even though it is definitely this attractive type of force, and I don't know what else to call it besides a force, even though Theoria would disagree, it is not very powerful. And of course, just like gravity, it's not very powerful, but of course it's not gravity, it's electrostatic. So anyway, that's kind of what I wanted to say about that, and we will definitely be investigating that considerably more. And the other thing is you simply cannot reverse the potential necessarily of the Earth to cause things to float up. That's why I think anti-gravity has been such a difficult thing to grasp, because first of all, people were looking for something that was entirely incorrect. However, we have things that when you go back and you watch this Thornhill presentation, he starts talking about the gyroscopic effect and how it basically starts concentrating the electric charge, you know, outwards of the things that are spinning. And this is one of the things that gives us this seemingly anti-gravitic effect, because you can spin up a 45-pound object, you know, like I think it even has it at the end of this video, where the guy spins it up and he's able to lift that 45-pound object up basically with one finger above his head. And this would appear to be one of those things that is a mystery about a gyroscope, but yet Wall explains it very well as to what's happening with the static potential. He's basically changing that static potential so that it's going in another direction, and therefore it has a quote-unquote anti-gravitic appearance or effect. So this is where we want to go with our research on this, guys, because it's, you know, there's no doubt in my mind at this point. Well, there wasn't before, but now it's like clear as a bell that this gravity thing that we're talking about is indeed electrostatic, and that's just the end of the story. So,
right. And, you know, you'll get a lot of people, because I had argued back and forth a bit with some people who, you know, I had postulated that gravity, or, you know, this downward tendency may be an electromagnetic sort of thing. People would argue, well, you're not made of metal, so, you know, how can you be attracted to a magnet? But that's not what this is. This is more like, you know, if you rub a balloon against your hair and pull the balloon away, your hair's not made of metal, but it'll be attracted to the balloon. So it's, you know, a very similar thing. So yeah, so you wouldn't have to be made of metal in order for this electric potential, or the difference, you know, the differential in the electric potential between the ground and a couple meters above your head, or way up in, you know, in the sky, in order to have this downward tendency affect a non-metallic object.
yep, absolutely true. So there we go. So anyway, I'm going to move forward on the, you know, on investigating this, but I find this whole harvesting atmospheric electricity, this concept, to be awesome. And of course, we know that Tesla was all about this, and you know, and I think that this is, you know, at this point now, I'm definitely going to be looking into it very deeply, because I think that, you know, with a potential of 5 million volts over the area the size of the Earth, even if the static current is extremely low, by the time you take it into, when you get it into the realm of that much voltage, and then cumulatively over the face of the Earth, you additively create more and more current. And so the electrical calculation for determining the power of something is very simple. It's called P, which represents power in watts, equals IE. And that means I is represented as current in amps, and E is voltage in volts. So if you have 5 million volts, okay, then if you had simply, well, 1 amp of current, of course we don't have anywhere near that, but I'm talking about a cumulative thing. But to give you an example, if you have 5 million volts of electricity and you have 1 ampere of current with that, that gives you 5 million watts of power. That's simply in the static, in the air itself. Now, we can, obviously we're not going to get 1 amp because it's actually broken down, and there are calculations for it, but there is enough area, I believe, that if you get a large enough collector of this static electricity and you get it high enough in the air, then all of a sudden you're going to be able to start being able to generate some fairly significant power. And this is something that doesn't go away. It's there all the time. So there it is. And this is exactly what these people that are trying to harvest electrostatic energy are doing. They're launching these collector plates, or actually they're not plates, they're more pointed objects, because for some reason electrostatic energy seems to be attracted to things that come to a very sharp point. But let's see. But yeah, so he's showing here, like here's a collector and it's got these pointed, very sharp pointed objects off of the sides of it. So this is really fascinating, and this has really opened up my eyes in a lot of ways, and this is one of the things that I think that our research group, especially those that are inclined to be looking into the electrical side of things, is going to find some very interesting information. And that's why obviously they're wanting to suppress all this free energy, and it is all around us, always has been. It's just a matter of collecting it. So once they come up with a technique where it can be collected en masse, and you know, you think about the ways they could do this. They could put those little pointy collectors on the top of the windmill generator. So even if there wasn't wind blowing, they're still going to be tapping off that electrostatic potential. And obviously the higher in the air we can get it, the more electrostatic potential we have to tap off of. And you know, that helps that equation of P equals IE. You get the E up, and you don't have to have a whole lot of I. When you got all that voltage, you don't have to have a lot of current to be able to yield out that P figure in watts, power in watts, that's usable power.
Yeah.
So there you
Yeah.
have it.